Hello once more, or hello at all to those just joining for the PointSense Heritage session. First, let me explain what PointSense Heritage actually is. PointSense Heritage provides tools for users in the field of archaeology and historic preservation, which should help you to create your typical deliverables, such as image plans, layout plans, elevations, sections, and 3D models for documentation of historical buildings and archaeological sites. All this is done using laser scans and photographs directly inside your familiar AutoCAD environment. PointSense Heritage has quite a couple of features. Of course, the basic features like importing, clipping, and slicing of point clouds, as well as colorizing sections of point clouds. It provides tools for modeling as well as analyzing surfaces and volumes. With PointSense Heritage, you can not only create ortho images of point clouds, but also true ortho photos adding photograph information, and you can also combine point clouds and photographs and use them for monoplotting. If the point clouds are not very dense but you have high resolution photographs, you can draw on top of the photos. I will show you how this works. And if you want to create nice image plans where you can measure true lengths of objects, for instance on the facade of things, you can unwrap point clouds and photographs to create those image plans. We do provide also multiple image processing, real photogrammetry inside PointSense Heritage, and as in every PointSense product, we do have Vertiserve with a planner view option to assist navigating the scans. Let me start with some basic features. Of course, you can clip the point clouds to remove obstacles and crop areas of interest. You can define slices or sections to create profiles for layout plans or for elevations. And in version 15 of PointSense Heritage, we added some additional clipping tools like the circular or ring form clipping tools to clip cylindrical regions, and also a fast tool for cutting rectangular sections out of the point cloud. We still have the option to colorize point clouds to create nice colorful elevation maps or to visualize areas thematically by age dating or by material, as you might need for archaeological sites. For modeling and analyzing surfaces, we have quite a number of tools. Some are pattern recognition tools for fitting lines and polylines to the traces of point cloud slice, and if you have those profile lines, you can of course combine them with the AutoCAD commands to create 3D models. We also have a cylinder fitting tool where you just pick 2 points on the cylinder surface and create the cylinders, and of course you can also fit planes and use them for defining user coordinate systems or for 3D modeling to get sharp edges and stuff. We have improved the fitting polygon tool to help digitized curved outlines or contours more efficiently. This is new in version 15 of PointSense Heritage. Can be used for cross-section profiles and stuff, and you just have to click a few points for approximation, and the algorithm will add more vertices and increase the number of vertices to fit the polygon smoothly to the trace of the point cloud. This is something I like to demonstrate briefly. I'll open AutoCAD. I have already prepared a smaller section of a point cloud. I'd like to show you the rectangular clipping tool briefly. So it's really quick clipping, and as mentioned, you can define slices. In this case, I will do one parallel to XY plane of the user coordinate system, and pick one point and do a slice thickness of just 5 centimeters, and then I will switch to the top view. And you can see we still have a small gap of this window section, and if I want to define a different slice, I can just move the slice upwards like that. And yeah, as I promised, I wanted to show you the polygon fitting, which is helping us to fit more curved outlines. We'll switch off the object snap and just draw the approximation. See, just a few clicks close to the line, and then run the fitting, and the webinar takes a bit longer than normal, and yeah, you can see line has been fitted very smoothly to the curved outline. And if I want to, I could even run the extrude command and create 3D model from that contour line, but time frame is tight, so I will go back to presentation to introduce some more useful features of PointSense Heritage to you. Another new feature in the PointSense products, not only PointSense Heritage but also in PointSense Pro and Building and Plant, is a tool for Flatness Analyzes. This tool is very powerful. You can use it for solid modeling as well as for volumetric calculations, but also for analyzing and displaying deformations of nearly planar objects. But it's also suitable for terrain modeling. The accuracy of the results can be controlled by parameters, and optionally you can display the deviations from a reference plane in an exaggerated scale, and also the reference plane itself, as well as the alignment of the deviation grid can be defined very flexibly. This is something I'd like to show you as well. And I have prepared a drawing. You can see the point cloud of a brick wall, which unfortunately has been scanned only from one side. So we can only model one side of it as a solid model. I also already fitted a kubit plane to that brick wall, an average kubit plane which lies inside the point cloud, and one I have put parallel to the previous plane. If I want to create a solid, I would use the offset plane to calculate the solid. If I want to analyze the deviations, I use the plane inside the wall. Let me just run the Analyzes tool, which is new. I will select the reference plane. I'm interested in the deviations, so I'll select the one inside the point cloud. And on the right hand side you can see what types of results you can define. So you can either create a solid for modeling this wall, or you can create a polyline grid. You can even create a point cloud, which this can be done because I can write the deviation values into the intensity column of the point cloud. And this is a trick to help me to colorize the point cloud using the AutoCAD tools for showing them in a colored way, by intensity way, but instead of intensity it's coloring the deviations. I will show you in a minute. And as I said, you can define parameters to control the accuracy. You can define how far from reference plane you want to consider points of the point cloud. You can set an exaggerated scale if you're interested in the deviations, but if you're interested in modeling a true volume solid, you should rather leave the scale factor to 1. And especially by defining the cell size of the grid, you can also increase or decrease the precision of either deviation analysis as well as the detail of the solid model that's been created. Once you've done all your settings, you start the Analyzes tool. I won't do that right now because with the webinar on and the tight time frame, it will take a while, so we'll cancel it, but I have prepared some results so you can get an idea what the results might look like. Let me show you first the solid that can be created using this tool. Here I used for that result I used a grid of 5 by 5 centimeters. If I want to have more detailed solid model, then I would need a denser grid. Another thing you can create is a deviation grid of 3D polylines. This one has been created without exaggeration, and you can see that the deviation values are written to the nodes of the grid. And if you export the point cloud by the help of this tool, then you get one where you can which you can colorize using this intensity option of AutoCAD 2015. And as I said, it's not intensity values this time, it's the deviation values which we've written into the intensity section of the point cloud. And of course you can also create a legend. I've prepared that one. Okay, I think you got an idea. You can create reports, visual reports this way, or you can create volumes and 3D solids. It's you who define which results you want to create with that powerful tool. We have similar tools for cylinder-shaped or conical-shaped objects. The conical-shaped objects have been added new in version 15 of PointSense Heritage. You'll find that tool also in PointSense Plant. The point cloud can be unwrapped for easier analysis. The deviations, you can color code the point cloud by deviations. You can create reports and export the data into Excel sheets or ASCII formats. And you can create same deviation grids unwrapped into the plane. And of course you can calculate volumes at different intervals, but I think for Heritage this option is not as much of interest as for the PointSense Plant people for tank analysis. There's another new feature in PointSense Heritage with the version 15, which is the recap photo import. Helps us to have a fast and automatic way of image orientation. So you can now use the web service of Autodesk, recap photo. You just upload the photographs of your object, and recap photo will calculate a point cloud and will give you oriented photographs back. The image orientation of this web service is pretty good. The point clouds are not as good. You can see that the edges are blurred and so on. But you can use those results, import them with a new import tool, and use them for image, multiple image processing, as well as for monoplotting and for creating true-to-scale image plans and orthophotos. Multiple image evaluation is done with a classic photogrammetry, and it allows you 3D modeling and creation of plans of structured objects even without using laser scans. Show you in a minute. And also monoplotting is nice to have for heritage tasks. You can draw on the high resolution oriented photograph, and the geometry is directly created on top of the point cloud surface. And let me jump back into AutoCAD to show you. I'll just close previous drawings, and yeah, inside PointSense Heritage in the image modeling section you will find the new recap photo import, and you just have to select the recap photo project file, which you can download from the cloud service. And you can see the top left, this project contains 34 photographs. It takes a few seconds for the software to read all the thumbnails of those oriented images into the list, and then you can select a number of photographs you want to use for evaluation. I just pick those two, and I will also insert the associated point cloud. I can zoom to the point cloud, and I will close that recap import once more. I could add more photographs as I needed to, but for my presentation it's sufficient to have 2 of them. You can see the point cloud. As I said, the edges are blurred and the point cloud is not very accurate. Other than the photographs, the orientation results are pretty good. We have done several tests, and yeah, let me show you. This is AutoCAD 2015, so I can switch to a different visualization of the point cloud. And the point cloud itself is not very dense. And first I want to show you some monoplotting functionality. So first of all, because of the very inaccurate point cloud, I will fit an average plane to the point cloud. Sorry, I'll delete this one. Click more. I have to enable the object snap first to pick the points on the cloud. Okay, that's, I think, sufficient. And I can now also set the user coordinate system to that plane, like that. And once I've done that, I can use monoplotting to draw on the surface of that plane. And to do so, I will just define 2 viewports, and I will switch one to camera navigation view of one of the photographs. And I will also scale the photograph in a way that it is in the background of the geometry. So I'll make it large. Alright. And let me pick the point cloud and make the point size a bit smaller. And let me zoom into the arc over here. I will show you how you can use monoplotting tools just to draw the arc. So you just run the AutoCAD R command, turn off the snapping, because I don't want to snap the point cloud. I actually just want to pick the sharp edges on the photograph to draw the arc. And as we are in AutoCAD, I can also just run the extrude command, pick the arc, and pull it so we have the arc in 3D. And if I just turn back the point cloud and go back to just one viewport, and make the image small once more. Okay, you can see that the arc is nicely drawn in 3D at the correct location, but with sharpness and more precision than with the point cloud itself. One more thing I like to show you is that we can draw 3D even without using a point cloud, just by using oriented images. For multiple image evaluation, we have a nice command that helps us generating the viewports and camera navigation mode. And just to give you an idea, I will just digitize the 3D line of the edge on the facade over here. I will just run the line command of the multiple image evaluation tool, pick first point in the first image, and the software will help me to pick the corresponding point in the second image by drawing this so-called epipolar line, so where it intersects the edge in the photograph, the corresponding points has to be picked, and do the same for the second point of the line. Click in both images. Ooh, this webinar software is really slowing my computer down. Alright, so I've picked them in both images, and the line is drawn directly at the location of that edge. To prove it to you, switch back to one viewport and turn on the point cloud once more. You can see the point cloud is blurred, but I have a straight and sharp edge digitized by the help of the photographs. Few more functionalities I like to introduce to you. I already mentioned that you cannot only create ortho images or point clouds, but you can also use photographs to calculate true ortho photos. This way you can plot high-resolution point clouds or photographs with best quality, and you get dense image information. You can use the results as image plans, because everything which is parallel to the image plane is projected to scale. But be careful, only those things parallel to the image plane are to scale. So if you want to have true length of other things which are not parallel to the image plane, you have to use a different tool. And this is the tool for unwrapping point clouds and photographs into the plane in order to create image plans. And it's useful for towers, walls, facades, ceiling frescoes, and more. And I really recommend digitizing on the and evaluating details on top of the resulting image rather than digitizing this 3D unless you really needed 3D. And in the results, as I mentioned, you can measure true length. As time frame is short, I will not demonstrate it live, but here is a brief example. You have a point cloud of that mosque. We fit the cylinder to that point cloud and then unwrap the colored point cloud, or if we have photographs, we can also unwrap those photographs, which might get us a denser result. But we cannot only unwrap cylinders, we can unwrap all kinds of shapes like this. The only precondition is they have to be straight into one direction at least to be able to unwrap them. And last but not least, I'd like to mention the planner scan view. With a photo-like display, more intuitive navigation than inside a point cloud, no accidentally snapping of hidden points are the advantages of this scan view. And you don't have to load the point cloud into AutoCAD in order to be able to use it. For those who didn't join the VirtuSurf session, here's a very brief or short video. On the left we have the photo-like scan view. Points are clicked in there and the geometry is drawn directly inside AutoCAD. So, nice thing to have in addition to the other tools, I guess. Let's summarize. With PointSense Heritage you get flexible evaluation with a combination of laser scanning or point clouds and photogrammetry. And as you can see, it adds multiple features to the native AutoCAD feature.